So today we're going to be doing the design for a social graph for LinkedIn specifically, where you see there will be like the second degree connections that you can search through. Another common, I actually interviewed at Snapchat like a year ago, and they also actually have this like social graph thing for their user base. And they actually handle more than 1 million TPS. So we're going to be using that number for our read scale today. And we're going to be assuming a 100-to-1 ratio of reads to writes. What's really interesting about LinkedIn's search is that they show the second degree connections. They don't just do your first degree connections, which is what Snapchat does. They actually do have second degree connections. And so you might think that a graph database might actually be pretty applicable here. And we're definitely going to talk about that. It's in the agenda over here. And then we're going to talk about how to not use a graph DB because they actually do have some scalability limitations. So we are definitely going to do it in another approach as well. And we are just going to focus on that. That is all we're going to be handling today. It should actually be an interesting topic. When you guys requested this, I've actually not heard of it in a real interview, but it's very fascinating. It's a very fascinating little thing. So that's why I want to go ahead and cover it anyways. Even though it's not really I've literally not really heard of social graph being used in an interview anywhere, but it's pretty fascinating. Yep, it's the social graph. You can do a search for people that have specific attributes, and it'll show you can filter for secondary connections, third plus, first, and then we're going to distinguish followers from connections. So the celebrity issue did have an opportunity for becoming pretty prominent here because some people have more than 50,000 followers. And so that would be like a very prominent, that would be a huge issue, but we're going to distinguish followers from connections. I actually did look into this recently once, is that if you want to be like a LinkedIn influencer, you can hit this little thing, this toggle thing that makes your account a creator account, I think is what it's called. And then instead of having a connection request, you just have this follow button. And then people click on that. You don't have to approve it or anything. And so that should help a ton with the celebrity issue. I think if you, there might be a limit on the number of connections you can have. I don't know if it actually does. I see a thing in the chat. I agree too. This is going to be interesting. Somebody's asking, what is a social graph? I'll need to answer that question too. So I'll answer these questions, then we can go ahead and jump into the diagrams. So feel free to share any of your questions so I can get to them before we do that. What's a social graph? Somebody shared the connections limit. I really appreciate that. I'm like, I'm sure there's some kind of limit for how many connections you can have. I didn't know exactly what it was, because if there wasn't a limit, there would still be some people that might be trying to use connections in the same way as a influencer and like not actually switch over their account. So yeah, thanks a ton for that. So it's just the users DB. It's basically users DB, but it can commonly you commonly hit it with analytical queries, and it's common to think of your user base as kind of like this graph kind of thing. And so I think I've heard it used called a social graph. I've actually been trying to figure out the exact proper word or term for it ahead of this session, but I'm pretty sure it's usually called a social graph for how people usually set up a users DB in the context of a social network. And I'm pretty sure that the term is social graph. So it's basically the users DB for any social network though. Would love to, if you could touch on computing second, third, and if you feel, I don't think it goes all the way up to the fourth degree. I think it does only show 1, 2, and 3 plus, so it's not as crazy. But I do have a pretty good idea of how to handle that, and I do specifically want to tackle that today. Yeah, so I do plan on tackling that today. I don't think it goes to the fourth degree, although I think you'll be able to generalize my approach to handle that as well if you wanted to. I just don't think it does go that far. But the core problem, yes, I'll be handling that. pre-compute inefficiently, so maybe account for clustering and caching. There's definitely, so you do perform, we will be performing the work upon adding a new connection is the way that I think it'll work. Number of nodes grows very fast. The third degree is already 50K nodes on average. Yeah, it's we'll get to that. We'll get to that. We're getting it. We might be getting ahead of ourselves. Yeah, okay. I think I've handled all of the questions aside from what we have today, like the actual problem. So I guess yeah, 50,000 nodes is okay, that might be we'll start jumping into it. So first we're going to go ahead and talk about the graph database approach. Let's go ahead and start with that. There's two paths here. One of them is the write operation, and then one of them is the read operation. So we're going to start off with the write operation, maybe talk about the schema a little bit, and then we'll get into yeah. So we'll have a user adding connection, and we'll have user searching for connection with a specific attribute. And then you'll have the backend, and we'll have a database. And for the first case, we're going to start with just the GraphDB, which is not going to be the most optimal approach, but everyone, we need to talk about GraphDBs because everyone will, of course, when you're new and naive, you're of course going to jump to GraphDBs as a shiny, fun thing. And so we have to cover it. So this will be the user write service is what we'll call it. And then we're going to have the search service. We'll have the search service over here. Okay. This will be the user data store. So you do a write connection, you have your request go in. We need to have the appropriate there. Okay, so that should look right there. Okay. And then you're going to have the write go to the database. It gives you a 200 request, 200 okay, it's succeeded, and then you get your 200 back all the way to the browser. Okay, we've written it to the database. And then we're going to need to talk about the schema for this. Let's hold on. So you're going to have a similarly request goes in, request hits the database. You'll have a list of records come back, and you'll pass those over to the browser. So that is a super high level of how it works. We need to talk about the schema again. So here we're just doing a graph database. I've actually not really used one myself before. I've just kind of like read about it. I know there's like Neo4j, and I think it has like a 1 billion node limit or like 10 billion. And there's some hacks that you can get for sharding it. Yeah. Go ahead and nope, don't need to do that. So you'll have like a user ID. And let's say it's like 3478. And then I think each property is actually also treated as a node all of its own. And then you somehow add a connection to, you'll have this other node of this other user ID. Say they are 5679. And then you add a relation between them. And it's, I believe it's kind of like its own, like each attribute is actually a node, I believe, in a GraphDB. And so like you add a connection between these two things. And I think that's kind of like a record or something. It's weird. But yeah, each piece of information is what you connect to. It's not like you have like a record and then you it works a lot like RDF format, I think. And so you have a thing between 3, 4, 7, 8 and this thing. We need some kind of nodes and edges. Okay, so we've got, yeah, so this one is this one's a node. I think you probably have like a node ID, and then that's the relation between them. And the advantage of graph DBs is that they are very the syntax is makes it really easy for doing traversals of it, for making recursive SQL calls. And so it's really good at doing these like recursive things where you're doing like a BFS style thing over your database itself, which is of course going to be horrendously expensive, but it's like very convenient to work with, very poor performance. Let's go ahead and put in some numbers for the scale here. So the writes are at 10K TPS, and then you have 1 million TPS of reads. And although that write operation is going to be pretty efficient here, it's lower TPS than the reads. If your write operations were a little bit higher than the reads and this whole thing was low volume, I think this would be pretty acceptable. So like if this was like LinkedIn's earlier days, like the first few years of LinkedIn being a thing, maybe a graph DB would make a ton of sense. But in this case, just due to the scale and just how expensive those queries are going to be for each of those, it's not going to make sense. I actually have talked to some people that have worked with a graph database before, and they told me that they added like a couple of caching layers. There's actually like 2 different caching layers for trying to not hit that graph DB like as often as possible. They're trying to absolutely minimize how often the graph DB ever got hit in production. Yeah, so it's not a great approach. And so I myself have not like used it a whole bunch, but I've heard it's like every single individual property is its own node. And then you do this thing where like you recursively collect records out however many degrees. And you can have these like predicate filtering logic things, kind of like RDF. And so you're doing something kind of like I don't even know that it's select the first user where college, like you might be trying to find IIT grads that are second degree connections, and you might limit it somehow. I'm not super familiar with the syntax. DDIA actually covered the syntax in one of the chapters, but you can apply a bunch of filters like that. And so you can also be like, and company is can do Amazon, and it just somehow there's some extra syntax that makes it recursively call out like it'll then check the connections of your connection. There's like a thing you can do for that. I see a bunch of messages in the chat. I'm probably butchering this information a whole bunch. That a particular user created a particular post. We're not going to be covering posts in this. But do we need some kind of nodes and edges? I'm fairly certain that somebody it's like you have nodes and then you have like a relation between them and you recurse over those. Okay, I think we can model post other activity using relational DB. Graph DB is to compute stuff. They used to use SQL in early days of LinkedIn. That would make sense. That would yeah, a lot of people start with SQL, and you can actually scale it pretty high. YouTube actually still uses SQL. I think they use something called Vitesse. So you know, I'm going to post that into the text file because I stick that in chat and in a pinned comment afterwards. And then you guys can have a tool called Vitesse. And so this text file is going to be in a pinned comment afterwards. If you guys were looking for this specific term, that's why I did that. Okay, so graph DBs, we're moving on to my second agenda item. I actually spent less time on this approach as I was a little bit less than I was expecting because they're bad. Graph DBs are bad. So 1 billion limit on node count, maybe 10 billion. And then also there's, I think it's kind of bad latency. You're doing this huge analytical query that's traversing a ton of your nodes. It's like, it's an OLAP query. And so you're like, it's horrible latency. You need to like try and pre-compute stuff as much as possible, particularly when it's read heavy like this. There's also sharding is a challenge. Sharding is a challenge. You can do it. I've heard nowadays you can do it. I don't know how well you can shard with a graph DB. And then what about like regions? If you have multiple regions that you want to have it supported in, you should probably have it replicated to those regions. With a graph DB, that's going to be hard. So like I said, sharding is a challenge. And so usually I think you just set it up with a single machine running the whole thing. You just host the whole graph DB off of like one machine. But I've heard there are tricks for sharding it. Yes, it's definitely going to be expensive. It is. It's so the advantage of graph DBs is not performance, it's the convenience of the syntax. So we're going to write that down. The advantage of graph is not performance. They just don't actually perform particularly better for graphs and graph traversals. That's the misconception, is that they actually might be more efficient somehow with that data. It's the convenience of the syntax for doing those recursive SQL queries that you would usually do. So you don't get a graph DB for performance boost, you get it for the convenience of doing those graph traversals. Yeah, it's somebody said, so I was talking about YouTube briefly above. Somebody was saying something about SQL, and I wanted to call out like, hey, you can actually get SQL to scale. YouTube does it. They use Vitess. So that's correct. They don't do anything with traversals. It's just that they do use a relational SQL database is what I was trying to get at. Yeah. Yeah, they just do use like PostgreSQL or some kind of relational database. So you can't actually scale it. They managed to do it with a tool called Vitess to make it easier. The usual reason why you don't use relational DBs is that it's a lot more operational work to have to manually partition things and manually scale it up. While with NoSQL, like if you're using DynamoDB, you just go like write TPS ++. You just like tell it like, hey, crank up the write TPS, and it'll do it all under the hood completely for you. And so yeah, Vitess makes it a little bit easier though. Yeah. So that's why I wanted to cover this is yeah, it's not more performant for graph DBs. That's a common misconception. That's a very common misconception. Okay, well, so now we've covered what I wanted to cover about graph DBs. I felt like it was just kind of crucial to go ahead and cover this just as a naive approach. In fact, that's going to be in the thumbnail afterwards, is naive approach graph DB, because it's so common for people to think like, oh, I have like these traversals that I want to do. Like, yeah, that might make it like, maybe a graph DB makes sense here. And it actually is not better for performance at all. It's just for convenience. Yeah. Okay, so now we've covered that. Now we can go ahead and move on to our next approach, which is that we're going to do a fancy fan out thing. So feel free, if you have any more questions about what I've already covered, feel free to post it in the chat. Otherwise, I'm going to move on to our next approach, which is that we're going to use something other than a graph DB. And so when you are adding a connection, you have some user ID, you have a your user ID and the new connection ID. Which is 6789, sure. And now you're gonna, of course, write that one connection as a first degree connection, but you're also going to want to, I think you should like fan it out. We're gonna, okay, so we're gonna have a data store over here. It's gonna be a NoSQL database. Let's talk about the schema, and then we can kind of talk about like how we're gonna cover this, but it's gonna be some kind of fan out approach. So you're gonna have your ID, 3, 4, 5, 6, and then you're gonna have a whole bunch of records of connection ID. So we'll say that somebody's 2134 is an existing connection. You'll have the degree of that connection, and you'll actually only write 1 or 2. You will not store 3+, because 3+ is just people that, everyone is in the 3+ bucket. And then when you're doing the write update, you will only decrease that degree number. So if it's not already there, it becomes a 2 or a 1, depending on what's going on over here. So when you're fanning it out, you're going to do a fan out to all of your connections that, hey, I've got this new connection. Hey guys, all my direct connections, add this as a second degree connection. So you're fanning it out to there. And then I think, so this is like the connection data store. I think you would still maybe have, you might have 2 databases, and it first looks at the connections database, and then it second looks at the overall user database. I've been trying to think through exactly the best way to do it, but I know that you're going to have to do something with a fan out here to pre-compute some stuff. And then I think you should also inline attributes. So like when you're doing one of those things like, hey, I want to find somebody that went to this college, has this, you can do like current company and former company, let's say that they used to work at Google or something. So you can have like a bunch of attributes like this, but like, are you going to, you don't want to do a join over the network. Joins over the network are really expensive. So it's better to actually inline those directly into the table as well, is that you might inline some attributes. So you would have, so that would look like, this is not actually like the schema. This is like kind of how I do like shorthand. If you guys hadn't figured that out. So you might have like college is that, and then you have what is it? Current company is Amazon, and you could have their current location. That's another thing you filter down by is current location. There's fancy stuff like city, then state, then country. I don't recall, there's fancy social graph stuff for that too, or GraphDB stuff for that too, where you can do like city is located in state within country. It's going to have current city. You'd also have current state. So let's say they're in Seattle. That's where I am. Washington. So you would want to flatten that. So if you're able to do location drill downs by city, state, and country, you'd want to flatten that, so that way you don't have to do any kind of logic for determining city is within what state during runtime when you're doing the query. You shouldn't have to look that up. So you should just pre-flatten anything like that you want to do. And I think there's even like industry, but in total, there's only going to be like, I don't know, 10 to 20 attributes like at most over here. So it's totally reasonable, I feel, to inline those, because it's like at most 10 to 20, feels like a few hundred. You might want to do something fancier, but okay, I got a couple of questions. So that's like Twitter. When I say fan out, we're going to do something like Twitter. I'm going to draw it here in a second. You'll see. And joining over the network. So it's when you have a table in one database and a table in a different one. It's the whole reason why deep pagination is really expensive on a list, on a search page. If you you don't want to have some kind of analytical query where you have to like compare thousands of records over the network or send thousands of records over the network. You would turn bandwidth of your database into a bottleneck, and you'd have massive swaths of your database that have to go over your Ethernet cables, which is bad. So bandwidth comes in extraordinary bottleneck. So it's you want to inline this, otherwise you'd have this other data store, and then for thousands of records you would have to pull that data in for thousands of records, and that would be super expensive. And so like there's this one's more of like a connections data store, while this one would be more of the user data store. And so this is the first and second degree connection data for your search. And then you would have a secondary search of third plus degree connections. And I'd imagine, so usually when you do those searches and you select all the connections data, it like will still list this data first, I believe, because it's the more likely to be relevant. And so I think it'll first check this out, and then this is like a second query. But since it has it prioritized like that, I don't think that it would, you're not really doing a join over the network. So it's like not nearly as bad as it could look like. But you would want to, yeah, you want to inline that data when you're doing the fan out. Anyways, let's get back to let's get back to what we're trying to do. So we got this new connection that we want to have, and we're going to have a thing over here. We want to do a fan out like Twitter, where we're going to tell each of our first degree connections to add a second degree connection. So we're going to have one thing go in here. And then I want to have some task runners. We're going to back this up a little bit more for some space. We're going to add some task runners for doing the fan out. This is what Twitter does, is that you got the one little message go in there, and then you're able to return a success. This is going to be really expensive on if you actually, when you're doing the fan out, it's going to become really expensive. So you want to just put that one little thing onto the broker here, and we're going to be using Kafka, because we have we're still going to have 10K TPS, so Kafka is still going to be a good idea. And then it's going to return a success. You just have to pop this thing onto the broker, and then you're going to have your fan out workers. You have some fan out, call them workers. And so you have to pull off of Kafka, and they are going to pull a message off. They actually pull, I think, 10,000 at a time. So it's actually going to pull in 10,000 individual messages. But for each one, we're going to follow the same process, which is first, you're going to want to pull in all of their first connections. You want to pull in all of the first connections of each of the users. So you're going to pull in the first connections of me and of my new connection. And we are going to, let's label that first connections of me and my new first degree, me and my new connection. So me and my buddy get all of our direct friends. And then we're going to write a new second degree connection for all of them. So it's going to be a crap load of writes hitting it, which is what Twitter does. So we are just hammering it with a whole bunch of write operations, and that's really expensive, which is why we wanted it to go onto the message broker first, is that because this is a very intensive operation, we want to just pop it on there and get a 200 success back so that we can tell them, yep, it's going to happen, which means this is going to be eventually consistent, but that's fine. I don't think they expect to have a strong, consistent search on their first degree connection right away. So it's totally fine that we've got eventual consistency. We can just do something like DynamoDB, and it would be upgrade only. So if somebody already has a connection listed as a first degree, it will not downgrade it to a second. So it'll be doing these writes, and the way that it works is check if the connection between the 2 already exists. And then if not, you're going to upgrade the connection to a second degree connection. So then if it's already there as a first degree connection, you're not going to overwrite that with a 2. Because, you could have multiple connections that have, you could have multiple, when you're fanning it out, like one of your other friends might actually already be directly connected to the new connection you're adding. And you don't want to overwrite that with a 2. You want to keep it as 1. There's that mutual friends counter thing too. I think you would actually want to have that in line. You do not want to be looking that up on the fly. That would be something that like you might intuitively think a graph database is a good idea for. But I think you would also want to do, you would also want to maybe look that up while you're doing these write operations, is that you would have an inlined mutual connections line. Mutual connections count for when it's a 2. I don't think it shows that for 3+. If it's 3+, that would mean that we're going to do this a second round on on pulling in all of your second degree connections. So I really hope it doesn't show that for your degree connections, because that would mean that it's just fanning it out like wildly far. Well, actually, you would only have to look at your first degree connections, and then their second degree connections are where you would fan out the pre-computed counts to. So you would not have to recurse like 3 deep. You only have to recurse, you would still only be looking at your direct connections and counting up there. But it still would be a lot, it would still be a lot more. You would literally be doing, like, so somebody had thrown out the number like 50,000 or something. You'd definitely be doing like 50,000 write operations every single time that you add a connection, which would be pretty wild. And I only had a ratio of 100 to 1, that would mean that we would literally shift to being write heavy if we did that. And then you would actually want to use an LSM tree style database. So now it's actually flipping the balance. We have magnified that 10,000 write operation by a factor of whatever the average number of connections is. So I use a number of, 10,000. And I said the average 1K followers on average, 1K connections, because I was distinguishing from followers. You have 1K. I think that's actually kind of high. I think I only have like 500. I think 500 is a lot more fair of a number. We're going to use that. And so we've got 10,000 coming in this way. But then when you do that pull in, you're going to magnify it by 1,000. You're going to magnify it by 500, but that's on both people. So it still is going to be 1,000x. So still going to turn it into 10 million TPS writes after you switch over to the fan out, which is pretty crazy. Yeah, interesting. Interesting. You might actually want to do an LSM tree style database here. I think you might actually want to do an LSM tree. I was originally feeling DynamoDB. This one would want an LSM tree. This one would be a B tree. So you could still do a DynamoDB on the actual user data store, but for your connections itself, I think you would actually maybe want to do an LSM tree because it might actually be write heavy. So it might make sense to do like Cassandra or like I can't think of anything else besides. So Spanner is also an LSM tree, but that's strongly consistent. You don't need that kind of crap with it. Okay, I see the chat. So choose company and how far connections to include would get average salary. This the live chat usually gets removed from my videos when I try and trim off the 15-minute wait at the start. That's why I'm pasting it over. Okay. What if attributes like company have a tuple value? That's interesting. I don't think you actually want you are able to select first, second, and third. I recall that, which is why, so the first and second degree check marks you would use as a filter over here. And then third, being a check mark, is whether or not you actually do a read over here. I need to finish the read part. I need to finish the read part of this. Yeah, okay. We can maybe talk about this a bit later. Yeah, I'm gonna move on. I need to finish the read half of this. So got this in. I'm pretty sure this is how you would do the writes. And then like I said, Cassandra, maybe a good choice over here, and then DynamoDB is probably a good choice over here. And then this one is you're not going to have inline mutual connections count, and then that is just information of the user itself. There's probably more details than you would actually include on just the searchable ones copied to the connections data store. So the connections data store would receive a copy of anything that's searchable from this data store, because it's you should inline it. And then you don't have that, you just have your own ID. And we don't have that there. So that's what I'm imagining over here. And that's thousands of records over the network. Let me, oops, there we go. Yeah, now let's move on to the read. I have this, you got a request that comes in, and then you're going to do your key range query. So you're going to do a trip over to here first if the 1 and 2, if 1 or 2 is checked, and you're going to use those as filtering attributes over the degree thing. And then if you have the third plus thing checked, you would actually do that over here. Because if they're 3 or more, it doesn't matter what the actual degree is. The point is they're not going to be in this database, and so you're going to search against this one. I am so curious about how far out that mutual connections count is getting inlined. I really hope it's not at 3+. That would be crazy. That would be so much fan out. That would be wild. I hope they don't do that. So we do a search against the first and the second. Pagination is going to be interesting. It would actually be a little bit trickier. They might do something like in one of my videos, I said that you should maybe limit the pages to 10 or something. And if they try and go beyond that, you should say, hey, add more search criteria. Just that you don't. Oh, Elasticsearch could be, you could also use, maybe Elasticsearch is another. No, you don't have text search. I don't know. I was considering Elasticsearch briefly. Maybe for this, you might be able to do it here, but over here, I don't think you wouldn't want to do it over here. I don't think you would want to do it over here. And then you don't actually do text style search of people's profiles, to the best of my knowledge. And that would be why you would want to add Elasticsearch in the first place. So I guess it wouldn't actually make sense for the DB choices in either case. Anyways, you would do a key range query against both of these, and then you would return the result over here. And the pagination is another challenge. I don't want to dive into that again. I know I've covered it in a different video somewhere. I can't remember which one off the top of my head, but yeah, key range queries are, if you do deep pagination, we're clicking on page 1011 plus, it you again run into the issue of joining a bunch of records over the network. Yeah. Okay, I'm looking at the chat again. I'm pretty sure there are. I'm pretty sure there are. Have you heard about what happens when you send a tweet? How it gets spanned out to every single one of your connections? So what used to happen when Elon Musk would write a tweet before they added a special caching hybrid approach is that it would literally get written out to it would result in 10,000 or 100,000 write operations because that's how they do the write. That's how they do the tweets for normal people is that still when a normal person sends a tweet, it actually writes that tweet to each of your connections directly. So yeah, and then I don't know if that would really help a whole lot. I mean, if you're able to batch up these like files and just paste over these files, it eliminates network overhead. And so I can see that. Okay, I can see how there might be some savings from doing that, but I don't think the savings are quite that high, and it's totally normal to do a fan out like this. This is like what Twitter does, and like people send a lot more tweets. You send more tweets than you do add people. There's more tweets getting sent than connections getting added on LinkedIn. So this is not actually the craziest thing I've ever heard of. The thing that's doing this on Twitter is probably super hot. It's easily more than 10 million TPS for what's doing that on Twitter. It might even be like 100 million or something. I think I've actually heard of cases. I've definitely heard of a case where you have 60 million TPS for write operations. And this is not actually that shocking to me. Yeah, I knew this was going to be interesting here. You don't have this for the social graph of Snapchat because they don't have the 2-degree connection. But that's what made this social graph so much more interesting than Snapchat's is that I knew that this kind of thing is what might differentiate it. Yeah, that was a little shocking though. Inline is just, I mean, that you have a copy of this information, whereas it's stored over here. So you're not strictly storing just the connection data. So ordinarily when you're thinking of this data, you would think to just have only these 3 lines. But you don't want to have to join this table to this other one over the network and copy thousands of things on every single key range query of this. So if you didn't inline this when you do this, you would also have to do a join between these 2 databases and copy that over. So it'd be thousands of records getting read over into this every single time you do a key range query. And that would be a lot. Yeah, you don't want to do that. It just means you're duplicating the data over into the other one. It's just like a normal NoSQL thing. Yeah. So first and second are actually stored over here. It's the degree attribute. And then if it's any higher degree, just means that it doesn't exist in the connections data store. Because like it doesn't matter if it's 4th or 5th, if you're at 3 or higher, then it's indistinguishable for that 3 plus. And so it just means that you just don't even have to have it over here. Unless you're doing something with the inline mutual counts thing. That one's totally interesting. I have no idea how that would work at that. Like my current mind model of how you do that for 3 plus connections is that you're gonna do something interesting with the fan out. Should be a huge pain. Well, so tweet is I mean, there are different websites, but tweets get fanned out. And then connections are getting fanned out is my suggestion. And so the architecture is similar. But the world population tweets more often than they add new connections on Twitter. Like, how often do you click the send tweet button on Twitter compared to how often you have you've hit the add connection button on LinkedIn? You might personally not even have a Twitter account, but on average, when you look at the world population, there's tons of people that have thousands and thousands of tweets. In fact, even Elon Musk has like 10,000 tweets or something wild like that. It's really not that hard to find people that have like 10,000 tweets. While on the other hand, with connections on LinkedIn, there's actually plenty of people that don't even have a LinkedIn account. It's actually more common for people to have a Twitter account than a LinkedIn account. So it's on average, the world sends more tweets than they add people on LinkedIn. That's a pretty fair way to put it. Yeah, it just means that you have it's inline as in like I just think of like CSS. So like which is where you have something like you might have like a B tag, and then you'll have like style equals some stuff, as opposed to where you have a B tag with you'll have an ID equals little thing, and then you have like way up at the top, you'll have like the style tag. And so like then you have like a whole bunch of stuff over there. And then like when you inline it, it's just like directly, you do this instead. So it's like you have that directly with the other thing. It's like locality is the term I think of. There's locality of this data, and it's replicated. It's a replica. It's redundant. So you have two copies of this information, which is in normal relational database design, you're not supposed to do that. But in system design, it's common to denormalize databases a little bit because it speeds up the read operations. So when you look at the comparison of what your read TPS is relative to the write TPS, you're usually going to be pretty read heavy. And then also just with the way that NoSQL databases work is that you also have to denormalize them because it's they're not super friendly with joins. But even with relational databases themselves, I've read that when you're doing database tuning, you might denormalize stuff just to speed things up. That was actually a thing that happened with Twitter, and that's actually why Twitter had the fan out in the first place, was that they found that the joins on people's timelines, when they were doing the joins for building a person's timeline and sending it back on like homepage load, it was really expensive. The joins were super expensive, and so that's why they started to denormalize it and have it do this fan out thing instead of having the join occur like on the fly. It was way more efficient for to just keep it in that joined format, like materialized, and to just fan out the write operations like this than to keep redoing the joins within the database itself. And so it's denormalized, and so you copy it over there, and now it's inlined over in this thing. Yeah. Okay. Well, I think this is good for wrapping it up. If you have any further questions, you can, of course, leave a comment on the video, and I'll try my best to get back to you. I'm a lot more responsive on the Discord channel, and I did drop a Discord link in the live chat. It's good for the next 6 hours. I don't like to just leave it open for reasons. If you join, you'll see why. But anyways, let's zoom out for the people watching this asynchronously. Sometimes they like to just skip to the end and see the nice, pretty diagram. So here it is. Here's my nice, pretty diagram. And this will be located in, I'm going to paste this into a pinned comment in my YouTube comments. And of course, also in the Discord channel. All right. Thanks for joining me. I hope you guys had fun. I hope this has been a great experience. Yeah, I'll see you guys next week. Thanks again for joining. See ya.